This tutorial looks at ions, how they form, and how ionic compounds are formed. Here's the first part of specification content. This is at foundation level. When we look at the periodic table, we see that there are 8 main groups. These are the vertical groups here, which correspond to the 8 electrons that fill up most shells. The majority of elements are reactive, for example those very reactive metals in group 1 and oxygen and fluorine, which are the very reactive non-metals. But there is one group, group 0, which consists of very unreactive elements. In fact, they're called the inert gases because they don't react with other substances. Now, why is that? So this group is called group 0, not group 8 because it contains helium as well, which has got a full shell of 2. It's called group 0 because there are no outer electrons. The shell is full. They all are very unreactive and stable elements, and scientists believe that this is because they have a full outer shell, and other elements are therefore reactive because they don't have a full shell. Their outside shell is incomplete. And other elements react in order to become stable, in other words, in order to get a full outer shell. Let's look first at sodium. Sodium has 11 electrons in the arrangement of 2, 8, 1. Now, how could sodium get a full outer shell? I suppose it could gain 7 electrons to get a full shell, or, alternatively, it could lose 1. In fact, the sodium atom loses 1 electron when it reacts. And that 1 electron, let's not worry about where it goes to, leaves the outer shell, and therefore there's no need for an outer shell anymore, and the next shell becomes this one here, which is full. Now, this has now become a sodium ion. Why has it changed its name to an ion? Well, ions are charged atoms. Originally, the sodium atom had 11 protons and 11 electrons. In other words, 11 plus charges and 11 minus charges. Remember, neutrons have got no charge at all. So it had the same number of plus charges as minus charges, and when you add these up, the sodium atom had no charge. But now, the sodium ion has lost an electron. It's still got 11 protons and 12 neutrons in the nucleus, but it's lost one of its electrons. It's gone down to 10 electrons, and therefore only has 10 minus charges, which don't balance up the 11 plus charges of the protons. That leaves 1 plus left over, and therefore this has got a 1 plus charge. And when we draw the sodium ion, we draw the electronic arrangement of the ion, and then we put square brackets around it and a plus charge. Metals like sodium lose electrons in order to gain a more stable arrangement. They get a full outer shell. So metal ions form positive ions through losing negative electrons. Let's look now at a non-metal atom, chlorine. Chlorine has got 17 protons, 18 neutrons and 17 electrons, which arrange themselves 2, then 8 and then 7. Now, how can chlorine get a full outer shell? Well, it could either gain 1 electron or it could lose 7 and lose the need for that outer shell. In fact, chlorine gains 1 electron because this takes less energy to get a full outer shell of 8 electrons. Now, notice that this has also changed its name from being a chlorine atom to a chloride ion. Now let's look at how it gets its charge. The chlorine atom originally has 17 protons and 17 electrons, so it's got 17 pluses and 17 minus charges, which gives it overall no charge. But now that the chloride ion has gained 1 additional electron, it's now got 17 protons but 18 negative electrons, overall giving it a 1 minus charge left over. So when we draw the ion, we draw the electronic structure of the chloride ion, but we put a square bracket round it and a negative charge to show it's got a negative charge associated with the whole ion. Chloride ion, like all non-metal ions, gain electrons in order to get a more stable arrangement, in other words, a full outer shell. So metal ions lose small numbers of electrons to get a full shell and end up with a positive charge. Non-metals gain a small number of electrons to get a full shell and get a negative charge. Let's show the formation of a magnesium ion from a magnesium atom in the same way. If you want to stop the UView video, please do so, have a go yourself. But you'll need a periodic table. Magnesium is in group 2. It's got 12 protons, 12 neutrons and 12 electrons. So magnesium has 12 protons, 12 neutrons and 12 electrons. That means that the nucleus, which I'll just draw as a dot here, of the atom has got 2, then 8, and then 2 on the outer shell. So how will the magnesium atom form an ion? Well, it could either gain 6 or lose 2. In fact, it's going to lose 2 electrons. And if it loses 2 electrons, the nucleus remains unchanged. There are 2 electrons on the first shell, and then 8 on the next shell, but no need for a third shell anymore. Now, this is the magnesium atom. No charge because it's got 12 protons, 12 neutrons and 12 electrons. That's 12 pluses. No charge at all for the neutrons. 12 minuses, making overall 0 charge. But the magnesium ion, here it's got 12 protons and 12 neutrons in the nucleus, but it's now lost 2 electrons, so it's only got 10 electrons. That means it's got 12 pluses, no charge here for the neutrons, and 10 minuses, and therefore it's overall a 2 plus charge. So when we draw it with a square bracket around it and a 2 plus charge outside, and we call it an Mg2 plus ion. So when a metal atom, like sodium, becomes stable, it loses an electron. When a non-metal atom, like chlorine, becomes stable, it gains an electron. It's that same electron. So when sodium burns in chlorine, the sodium atoms each lose an electron to the chlorine atoms to make sodium ions and chloride ions. It's a kind of transfer of an electron from atom to atom. And here it's shown with the electron being transferred from the sodium to the chlorine to form 2 ions, the sodium ion with a 1 plus charge and the chloride ion with a 1 minus charge. And then these 2 ions would attract each other because they've got opposite charges. Therefore they have an electrostatic attraction which brings them together in a crystal lattice. When magnesium forms an ion, it has to lose 2 electrons. Oxygen in group 6 has 6 outer electrons and therefore needs to gain 2 electrons. So when magnesium and oxygen react together, the magnesium transfers 2 electrons across to each of the oxygen atoms, whereby the magnesium gets a full outer shell and the oxygen gets a full outer shell. The magnesium becomes a magnesium ion, Mg2+, and the oxygen becomes an oxide ion, O2-. Notice the names of these negative ions, these non-metal ions, tends to change in that they change to an ending with "ide", like chloride, oxide, sulfide and so on. Because there's a ratio of 1 magnesium to 1 oxygen, the formula of magnesium oxide is MgO. There's a ratio of 1 magnesium to 1 oxygen. But that isn't always the case. Here's an example where magnesium wants to lose 2 electrons to get a full outer shell, but chlorine only wants to gain 1. Therefore, we need 2 chlorine atoms to each gain 1 electron from 1 magnesium. So the ratio is 1 to 2. We end up with a magnesium ion, Mg2+, and 2 chloride ions, Cl-. So the formula of magnesium chloride has the ratio of 1 to 2, MgCl2. Notice that the formula of these ionic compounds doesn't contain the charges on the ions anymore, just the symbols of the elements which are in the compound. These ions that are made have got opposite charges and they attract each other by what's called electrostatic attractions or ionic bonds. So ionic bonds are made when positive and negative ions attract each other. A skill you need to know is to be able to work out the formula of an ionic compound given the formula of the positive and negative ions that make it up. Here's a selection of different ions, and don't be alarmed, you don't need to learn these, they will be given to you. However, many of them can be derived from the group that the element is in. So for example, sodium in group 1 will form a 1+ ion. Magnesium in group 2 will form a 2+ ion. Whereas for the negative ions, those in group 7, like chlorine, which will gain an electron, will become Cl1-. Those in group 6, like oxygen, which needs to gain 2 electrons, will be forming a 2- ion. So, working out a formula. Let's work out the formula of calcium chloride, given that we know that the calcium ion is Ca2+, and the chloride ion is Cl-. Now overall, the salt calcium chloride's got no charge, so it must have the same number of positive charges as minus charges. Now there can't be a 1-to-1 ratio, because if there were, there'd be 1+ left over. So the only way that we can get the charges to balance up is if we have 1 calcium to 2 chloride ions. That means we've got 2 pluses there and 2 minuses there. Now, when we write the formula, remember we don't put the charges in anymore, we just look at how many of each kind of element there are. So it's Ca1, Cl2, and of course we don't write ones in the formulas, so it's just Ca, Cl2. Let's work some other ones out, and let's start by writing down the formulas for the ions. Sodium hydroxide is made out of an Na+ and an OH-. Sodium sulfate is made out of an Na+ and an SO4, 2-. Copper sulfate from Cu2+, that's why it's called copper 2, and sulfate SO4, 2-. And ammonium sulfate from an Al3+ and an SO4, 2-. If you want to have a go at this, just press pause and have a go at them, and then I'll go through the answers in a second. Okay, answers. Well, sodium hydroxide has already got 1+ and 1-, so the formula of this one will just be Na1OH1. Sodium sulfate, however, has got 1+ but 2 minuses. So in order to balance up the charges, I need 2 sodium plus charges in order to balance up the 2-, and so the formula is Na2SO4, 1. Next one, copper sulfate. Now this one already has 2 pluses here and 2 minuses here, so it's a 1-to-1 ratio, Cu1SO4, 1. The last one is more difficult. The ammonium has got a 3+ charge, but the sulfate has got a 2- charge, and these don't easily balance up. In maths, we'd use what we call the lowest common multiple of 3 and 2, which is 6. So we need 6 pluses, in other words 2 aluminium ions to make 6 pluses, and to make 6 minuses we need 3 of these sulfate ions. So when we come to write the formula, it'll be Al2SO4, 3. But unfortunately that looks like SO43. It's the whole of the SO4 which is tripled, so we use a bracket around the SO4 to show that it's the whole of that which is tripled.